This is section 8.5 of accelerated geometry, and it deals with surface area. So I have these buildings on here, so if we wanted to paint some of these buildings, we'd have to know the surface area to know how much paint to get. If we wanted to put glass panels on, we'd have to know the surface area to figure out how many glass panels, and so on. So surface area is the sum of the areas of all of the surfaces of a solid. So we start with a prism. A prism is a solid that has two congruent parallel bases that are polygons and lateral faces that are parallelograms. So here are the two parallel bases, there and there. And then here are the lateral faces, which are, in this case, these side panels that go around. So this has 1, 2, 3, 4, 5, 6 sides. So therefore, there are 6 of these parallelogram sides to it. So if we wanted to figure out the surface area, we'd have to find the surface area of 2 regular polygons, so 2 1/2 SANs, and 6 of the parallelograms, so 6 base times heights, and we would add those together. A pyramid is a solid with one base that is a polygon and lateral faces that are triangles that share a common vertex. So here we have the base, and then we have these lateral faces, these side faces that are triangles. Okay, if I go from the top down, that's the height, and if I take one of these triangles on the side here and come down with its height, that's called L, or slant height. So if I were to figure out the surface area of these pyramids, I would have to use, in this case, 1/2 SAN plus 1, 2, 3, 4, 5 triangles, 5 1/2 base times height. Here, this is a rectangle base times height plus, and then I'd have to have 2 sides, 2 1/2 base times heights, because they seem to be equal, and then these front and the back are also 2 1/2 base times heights. A cylinder is a solid with 2 congruent parallel bases that are circles, pi r squared, so 2 pi r squareds, and a lateral face that is curved. Okay, so now, we're going to talk about this later also, but if this is like a soup can and it has a label on it that's paper, if I cut that and then open it up, I don't have a great room here, but it's going to be a rectangular piece. It's going to have the same height as the height of the cylinder, and then this around here was the circumference around here. When I open it up, this is also going to be the circumference of 2 pi r. So if I'm going to find the surface area, it would be 2 pi r squareds plus 2 pi r times the height of the object. A cone is a solid with one base that is a circle and a lateral face that is curved. And we're going to talk about how we find the surface area of that curved piece later on in this presentation. To find surface area, they say count the number of surfaces, draw a sketch of each surface, determine the area of each surface, and then add all of them together. Now, sometimes there are many surfaces, so it is important for you to be organized as you do this and to write stuff up so that people know what you have been doing. Because if it's just a little addition mistake that you make along the way or a multiplication mistake, it would be nice if it was nice and written out, organized, so that your teacher could find that little mistake rather than saying, oh my God, what did this person do? 4 points off. Okay. Now, find the surface area of this prism. So it has a top and a bottom. The top and the bottom are both 8 by 6. So here they did the top and here they did the bottom. And then it has 2 sides that are 3 by 6 in the left and the right. So here's one of the 3 by 6s and here's the other one. I don't like the way they did this connected. They should have separated those. and along here, 8 by 3. So here's 8 by 3, and then there's one in the back there that's also 8 by 3. Okay, so the surface area is 2 of the base areas plus the lateral surface area. So 2 length times width, 2 times 8 times 6, and then I would say 2 times 3, and 2 times, I say 3 by 6 here, this should have been 3 by 6. So 2 3 by 6s, and 2 3 by 8s. Okay, surface area of a cylinder. So there's the top and the bottom. Since the diameter across here is 10, the radius is shown to be 5. And then here's that soup can again. If I cut this and open it up, this across the top was the circumference. So the circumference was 2 pi r. And then the height is the height of the object, which was 12. So therefore, the surface area would be 2 pi r squared, 2 circles, plus base times height here, 2 pi r times the height. And then it says, place this formula for the surface area of a cylinder on your conjecture list at 8.5. So at 8.5, it does say surface area of a cylinder. Now, sometimes, like if it's a big oil drum that is huge, it's a big storage tank, and they say they're going to paint the surface area of the tank, they're not going to lift the bottom and paint underneath there. So sometimes you have to kind of use common sense and say, yes, this is the formula if we're using the top and the bottom circle. If we're not, then we only use one of those. If we're not doing anything with the circles, then we don't use any of that part. Okay, now the surface area of a cone. Okay, so when you open this cone up, you slice it and open it up, it looks kind of like this fan shape. And then we do something with it like we did with the circle when we were trying to come up with the formula for the area of a circle. We keep folding, folding, folding until we get these little pieces, and then we will rearrange these pieces, which are triangles, point up, point down, point up, point down, and so on. Now, again, when I did this before, I had a green marker that went across here. I could probably get it again if I'm not too lazy here. Whoops, I don't want that. I want the highlighter, and last time I did it in green, let's do it in green again. So this piece here used to go around the bottom here, so it is a circumference, 2 pi r. But when we put these up, down, up, down, up, down, half of the green ends up down here, and half of the green ends up there. So instead of this being 2 pi r, half of it would be 1 pi r here and 1 pi r here. So now it looks like a parallelogram. And in this parallelogram, I'm going to get a pen again, I have the base being pi times r, and I have the height going from here down to the other side. That's also going to be this L, which is that slant height again. So the surface area of a cone is, if I use the bottom, a circle, pi r squared, plus pi r times the height of L, pi rl. So also place that on your conjecture list at 8.5. Now there's one other one here. I'm going to skip that. I'll go to this one. This one in the homework gives people a lot of difficulty because you have to worry about what surfaces are really going to be covered. So if I take this is like a hollow cylinder and like a roll of paper towel. If I would want to cover all of that, there is the top piece right here, which is an annulus. So that's here. There's the bottom that is also, that's a hole, that's not there. And then this, so it's all this space around here again. So that's another annulus, and those are equal to each other. And then I have the outer piece. So if it's like a soup can, you cut it open and open it up. So this is pi r, half of, well, 2 pi r, the circumference, and then this is the height of the object. And then I also have the inside, which is going to be covered if I want to cover this paper towel roll. So if the inside is kind of a cylinder, it is a cylinder also. If I also cut it, it's also going to be a rectangle. And its rectangle is going to have 2 pi r here and the same h here. Now the radiuses are going to be different. I could probably make that be a capital R and this one is small r. So the total surface area would be an annulus pi capital R squared minus pi little r squared plus the same annulus, or I could have just done 2 of those. And this is 2 pi r h, and this is 2 pi r h. Or I'd probably make that be a capital R. Now when we get to volume, we're going to subtract out the middle. But when we're talking about surface area, we want the outer surface and we want to add to it the inner surface. So we're adding this all together. So be careful not to say, oh, I'm going to subtract out the middle. You're only going to subtract out the middle when you're going to be talking about finding the volume of a hollow cylinder like that. So that is enough information, I think, to have you be able to do well on your homework for section 8.5.